All right, so here's another example of power that would be a little less, I don't know, easy to visualize, I guess I'll say. Find the power delivered by the net force, okay, to a 10 kilogram mass at a time of 4 seconds, okay, given the position of the mass as this function, all right? So since it's a time-dependent thing, right, we want to know it at 4 seconds, all right, we're going to have to use the instantaneous method of this, okay? All right, so the first thing, let's see what we've got. So we've got 10 kilograms and we've got 4 seconds, okay? And this is also a time-dependent force, right? Because it's not versus x squared. That would just be a constant acceleration and a constant force. Since it's t cubed, it's actually a time-dependent one, okay? So that means we're going to have to use calculus, okay? So x of t equals 4t cubed minus 2t, okay? We take the derivative of that, right? That would be 12t squared minus 2, okay? And then if we take the derivative again, or the second derivative, it would just be 24t, okay? So see, here is where we're seeing, right, that's a time-dependent acceleration and therefore a time-dependent force. Okay, so it's a non-constant time-dependent force. All right, which means you're going to have to find everything at that time. Okay, force and acceleration, right? Because acceleration. Okay. All right, so at that moment that they're asking us for, okay, the net force equals ma. Okay, the mass is 10 kilograms. Okay. And the acceleration, right, is 24t. And we care about the time of 4 seconds, right? And I'm sure this has some units in here that are kind of missing, right? But that's going to end up being 96 meters per second squared. All right. Oh, not meters per second squared. I lied. Newtons. 96 meters per second squared is this part. 96 meters per second squared, so it's going to be 960 newtons. Okay, that's the net force. Okay, now if I want the power, right, I need the F times V, okay, and assume it's all in the same direction because we're not given any information. So 960. Okay, now I need the velocity, right, at 4 seconds. Okay, so 960 newtons. Okay, if I plug in a 4 there, then I'll get 190 meters per second. Okay, and then the power being 182,400 watts at 4 seconds, right? And you can see if the time is different, everything's going to be different, right? Because everything is time dependent.